In this video, we're going to go through some revision notes for EDEXCEL-Math Cambridge IGCSE for examinations in 2024 and 2025. In this video, we're going to be covering topic 14 in EDEXCEL-Math. This one is all about conversion graphs. It's a really short topic, so let's get started. What is a conversion graph? By definition, a conversion graph is a linear graph showing relationships between two quantities, allowing you to convert between two units by reading values of the graph at different points on the line. So it is a linear graph. It shows relationships between any two quantities that can be plotted on a graph. It allows you to convert between two units just by reading of the values on the graph at two different points. Why do we use conversion graphs? Some common uses include converting between units of temperature, units of currencies, and between units of volumes, and etc. So for example 1, convert 100 degrees Fahrenheit into Celsius by using the graph. If we look at the graph, on the x-axis we have Celsius, on the y-axis we have Fahrenheit. The graph is linear because a linear graph is a straight line through the origin. So at 10 degrees Celsius, it is 50 degrees Fahrenheit. So 20 degrees Celsius is 100 degrees Fahrenheit. So just plot up and down using rise and run. Wherever, if you look where they're asking for 100 degrees of Fahrenheit, find where is 100 degrees Fahrenheit. 100 degrees Fahrenheit is on the second block of the graph. From here, make your run line towards the origin of the or midsection of the linear graph and make your rise line downwards, and you're going to find the other value. Distance time graphs. So we have discussed these in the physics topics as well, so this is technically like a review for that. Distance time graphs or DT graphs tells you how large or small the speed is. In a distance time graph, the slope is the speed, so any change in the slope is the change in the speed. A slope, as we know, is rise over run, and speed is distance over time. So in the distance time graph, the rise is the distance and the run is the time. So speed is equal to slope, slope is equal to rise over run is equal to distance over time. Distance is on the y-axis, time is on the x-axis. Run is from distance to the graph, rise is from graph to time. Positive gradient is an object moving away from the starting point. Negative gradient is an object moving towards the starting point. A horizontal line shows that the slope is 0. This means the speed is stationary and the object is not moving. A straight line is constant speed. A straight line upward or downward is constant speed, but a straight line horizontally means the slope is 0, so there is no speed. Here are some types of distance time graphs. The first one, again, stationary because it's a horizontal straight line, so there is no speed. Objects moving forward, upward at a constant speed. Origin line starting from the origin, upward. Curve from the origin, objects moving forward, upward at increasing speed. Backward curve from the origin, object is moving forward and upward at decreasing speed. Straight line downward, object moving back and down and constant speed. Curve downward, object is moving back and down at increasing speed. Low curve downward, object is moving back and down at decreasing speed. So if you're getting confused with the curves, just remember the farther the curve is from the y-axis, the faster the slope. This means the faster the speed. So on example 6, the curve is much farther from the y-axis. This means that the speed is faster because there's a higher slope. In example 7, the slope or curve is much closer to the y-axis. This means that there is a low slope. This means the speed is slow. Rate of change. Rate of change is how a variable changes over time. Examples: speed, changes in distance divided by time. Acceleration, change in speed per unit time, which is change in velocity per unit time, delta v over delta u, v minus u over delta t. Number of ice cream sold as weather gets warmer, change in ice cream sold divided by change in temperature. This is how you're going to find your questions in the exam. Rates of change in graph. So steepness and gradient of a slope. We've taken this in physics as well. Steeper slope is equal to larger and faster speed, closer to the y-axis. shallow slope is smaller and slower speed. The slope of a straight line represents the magnitude of the speed. Decreasing slope is equal to decreasing speed, the acceleration. Increasing slope is equal to increasing speed and acceleration. Changing speed is represented by a curve. Let's just refer back to the initial graphs here. Yep, I think I misconcepted a point here. Just to clarify my point, the curve that is away or farther away from the vertical line in the graph is the faster one, and the curve that is closer to the vertical line of the graph is the slower one. So that's how you can make it easier for you to determine between the curves which one is faster and slower and which one is increasing and decreasing in speed. Okay, so a quick review, some 3 facts. Straight line is a constant rate of change, horizontal line 0 is no rate of change, and rate of change is larger when the graph is steeper, meaning higher gradient, meaning, yep, farther away from the vertical line in the graph. Speed time graph. We've also taken this in physics, so this should be like a review. Speed time graph shows the speed at different times with acceleration as the gradient. So in a distance time graph, it shows how large or small the speed is. In a distance time graph, the slope is the speed, rise over run, distance over time. In a speed time graph, the acceleration is the slope. So any change in the slope or the gradient is in acceleration. So acceleration is equal to speed over time, which is rise over run. So constant speed time graph slopes. A straight line up is constant acceleration and increasing speed. A horizontal line is zero acceleration because zero slope and constant speed. A straight line down is constant deceleration and decreasing speed. Curved speed time graph slope. An upward curve, meaning is sloping upward and speed and acceleration is increasing. Horizontal, zero slope, zero acceleration, constant speed. Downward curve, sloping downwards, so speed and acceleration is decreasing, and then again horizontal, so zero acceleration and constant speed. Calculating the distance of a speed time graph. The distance of a speed time graph is the area beneath the speed time graph. Area can be of a triangle or of a rectangle. Area of a triangle is base times height divided by 2. Area of a rectangle is base times height. A positive gradient is positive acceleration, speeding up. A negative gradient is negative acceleration or deceleration, slowing down. And a horizontal line, again, zero slope, no acceleration, but constant speed. And that is it for this topic. It was a really short topic, just like a review for physics. And if you have any questions, feel free to ask me in the comments below. I'll be more than happy to answer them, and I will see you guys in the next one.